So today we're doing graphs to equations, just cosecant, secant equations. There's going to be a ton of overlap between these notes and what we did previously with sine and cosine. In fact, we're actually going to dig into the graph and try to pull out the sine cosine curve to basically guide our thinking here. Before I do that, just the general information, the general equation that we use here. Y equals plus or minus A cosecant B x minus phase shift plus vertical shift. And then, of course, it'd be the exact same for secant, but secant will be in the equation instead of cosecant. Before I start getting specific to which equation I'm going to do first, let's identify the three variables that do not change from one equation to the next. The value of A always stays the same for the whole graph. The only thing that can change is whether it's positive or negative. It depends on what type of curve you choose. Is it reflected or not? So A always stays the same. B always stays the same. It affects the entire graph. And the vertical shift always stays the same. It also affects the entire graph. So I'm going to find these three things first before I start building my actual equations. These are the must-know items before you get that much deeper. So let's mark up the graph quite a bit. First off, I'm just going to really highlight the points that were graphed to make this graph that we now see in front of us. So we'll first start with the maxes and the mins. Our mins all are at 0 and our maxes are at 2. The only points that are missing are the midline points. Well, halfway between 0 and 2, this one you could very easily eyeball, is 1. 1 is where our midline is. And this tells us two things. This is the midline. True. Also, it is the vertical shift. They are the same thing. The vertical shift is a plus 1. So that's the first thing I can fill out down here is the vertical shift. I know it's plus 1. Once I find vertical shift, I can very easily find my A value. Remember, A is just how far up or down you go from the midline, and in either direction, it's going to be 1. So A equals 1 here. Now again, whether it's positive or negative, that can change from equation to equation, so I'm just going to say 1 for now. B, this is where we really struggle the most, is finding the B value. And especially on graphs like these that are a bit more complicated, you have to know what you're looking for. Last thing I want to fill in before I identify B are the asymptotes, because they're there, we just can't see them. Again, this you just kind of eyeball. So let's look at these two curves on the left side. You can see that they approach this line through negative 2 pi, but they're clearly not wanting to cross it. That's our asymptote. Sorry about that, I forgot to turn my quiz timer off. There are going to be some graphs where the curves are a bit farther apart, so identifying the asymptotes will be a tad trickier, but this one's pretty straightforward. And all of these intersections here, these are the midline points that we graph. Now we basically have what you would have graphed if you had graphed this by hand. One big difference is in graphs to equations, I actually want to draw the curve in with those points, so I'm going to do that. The reason I do this is to help me identify my phase shifts a little bit easier. So really, we're focused now on this middle curve I have graphed now, which is your typical sine cosine graph, your sine cosine curve. Now from here, we can treat this problem like we did with the previous graphs of sine and cosine, finding b. For this one, I'm going to go the easy route where we start at 0 for our first curve to find the period. And I'll go with this curve again. So if I'm starting here at 0 on the x-axis, it's the easiest place to find the period from if you're able to. Go out one full curve. And I'm not done yet, but I'm going to stop here for a moment. Which curve am I tracing, sine or cosine? Yeah, it's a sine curve. This is an S curve. So we start at the midline here. Max, min, we stop at the next midline point after that. Don't go too far. The other way you can see this is you go 4 points to the right. That's how you know you have a full S curve. I see some students who go all the way up to the next maximum before they stop. That's not quite correct. So this is a full curve, and it also happens to be a sine curve, so I'm going to use that to my advantage in a moment. But right now my only goal is to find the period. So I need a curve first in order to identify the period. So we start here at 0, and we end here at 2 pi. So 0 to 2 pi, 1 period, which is a curve, and this problem is 2 pi. Again, this is really easy when you start at 0 because you don't really have to do any math. For starting at 0, it's whatever number you end up at. Now, if you don't start at 0, it's not so easy. So in the next example, I will intentionally not start at 0, again, just to show you how different that looks. Reminder, the whole point of finding the period is to find that b value, because in order to find b, we use the formula period equals 2 pi over b. And you have to have the period in order to find that. We now know the period. We just figured it out. It's 2 pi equals 2 pi over b. And then I'll put this over 1 just for emphasis. Now from here, you are welcome to cross multiply and solve, but I hope at this point you can stare at that and tell me that b is clearly 1. If the tops are the same, the bottoms must be the same if they're going to be equal fractions. Just logically speaking, that's the only way it would work. So just jumping straight to that conclusion, b is 1. Again, if you need to do the work, you can. You should end up with the same answer. Questions on finding the first 3 variables? Now let's start building the equations, and I'll build them both at the same time. So cosecant equation, the plus or minus is still up for debate. So we're going to underline that there. Something needs to go there. Now a is just 1. Cosecant. B is also 1. We found that. X minus Phase shift will be determined momentarily, so I'm going to leave that blank. Plus my vertical shift is 1. We found all that information. And I'll do the same thing for secant below, except it's going to be secant. 1 secant, 1 x minus phase shift will be decided later, plus 1. The only things we need to find are plus or minus and phase shift for both equations. Again, from one equation to the next, besides changing the function, those are the only two pieces of information that will change. The rest of it will be exactly the same. From here, I'm going to start with whichever curve I found first to get my period, which in that case was the sine curve. Sine, hopefully you're well aware, goes with cosecant. So we're building the cosecant equation right now. And my circle here is my starting point for sine, my phase shift, if you will. Phase shift of 0. And again, that's for the sine slash cosecant curve. So up in my equation, I'm going to write 0 for the phase shift. And then for the plus or minus, you just look at the curve. We start at our starting position and we go up from there. That's a positive movement. We have a positive 1 for our A value. There's nothing wrong with leaving this equation like this, but we can clean it up just a tad bit. Y equals, I'll drop the 1, cosecant. X can drop to 0, plus 1 at the end. That is the better version of this equation. And now for the secant equation, again, secant pairs with cosine. So they will have the same starting point. So find a cosine starting point. Cosine starts at maximums if it goes the unreflected, the normal direction. And then if we go for a reflected cosine, we would choose a minimum. But I always go for the path of least resistance, so I'm going to choose a maximum. Now you've got 3 maximums to choose from here. You can go with any of them. You don't need to see the full curve. But if you want to see a full curve, then either go with one of these two. One other factor to consider. Notice that the maxes lie on numbers that I have not found yet. So the easier ones to identify are going to be closer to 0. So for that reason, I'm going to choose this one here. So yes, my colors are going to overlap, but that's all right. And again, cosine is an easy curve to find. It's just maximum to maximum, like that. It's a full U. And I'm starting here. Reminder, your starting position goes on the midline, not at the maximum. I mean, here it doesn't make a difference, but on graphing, it did make a difference on the last test. And so that's our phase shift. We still need to identify what this number is. Take a closer look here. Again, this number here is 0. And this number is pi. This is just fractions. We're going from 0 to 1. What's halfway between 0 and 1? Come on now, what's halfway between 0 and 1? Thank you, 1/2. So this is 1/2 pi, or pi over 2. So my phase shift is at pi over 2. And that's what I'm going to put in my equation. If you write 1/2 pi instead, that's fine. And this is the phase shift specifically for cosine / secant. Lastly, we need to determine if it's a plus or minus. I've already said this. I intentionally chose a maximum here so that it would be the positive case, no reflection. So again, much easier. And again, I'm going to rewrite this just so it looks a tad nicer. We have y equals secant x minus pi over 2 plus 1. And those are your two equations. Questions on this problem here, either equation, any of the parts. Okay, we're going to do that one more time on the back side. It'll go a bit faster since you've seen the process. Again, I'll write out that general equation just for reference at the top. Y equals plus or minus a cosecant b x minus phase shift plus the vertical shift. And the three important variables to find first thing, a, b, and vertical shift. Let's mark up the graph to find these items. First, I'll identify my maxes and mins. Our max is -2, our min is -4. Halfway, clearly between that, is -3. I didn't get too creative on these. So reminder, that means this is our midline, and it's also our vertical shift of -3. So we now know that vertical shift down here is -3. Amplitude, again, is how far up and down we go. Again, I didn't change much on this graph. It's still 1. It goes up 1 and down 1 each time. To find b, we must first find period, so we need a curve. I'm going to fill in the rest of the points that we don't know yet. Again, it's very easy to tell where the asymptotes are. It's the one line separating each curve that they're clearly trying to avoid. Now I can identify my midline points. It's where those intersect with the midline. And then finally graph my sine cosine curve. So now I'm going to identify a curve to find the period. And as I mentioned, I'm going to intentionally avoid 0. Again, just to talk about what if you can't start at 0 to find the period, what do you do? And also, 0 starts at a reflection, so I'm going to avoid that for another reason. So I'm going to look for either a sine or a cosine curve. Cosines start at maxes, sines start on the midline to start that S curve. Now here, sines, all the midline points, we don't know those values, so we're going to have to find them later. So again, the easiest thing for now is to find a starting place that has a value. So if we start with the cosine, here we know the values of the starting and the ending points. So that's what I'm going to use. So I'll start here at this maximum at pi over 2. And this will also be my phase shift. I'll use that later. Phase shift, pi over 2. And that'll be for the cosine slash secant equation. And then I'll trace the full curve. Again, it's maximum to maximum, the U shape. So that's one full curve, one period. We go from pi over 2 to 3 pi over 2. And again, this is one period, which is a curve. Now this time, and again, I'll have students who will do this. I can't just look and say, oh, the right side is at 3 pi over 2, that's my period. No. You have to find this distance since we're not starting at 0. So you need to subtract the right minus the left. So 3 pi over 2 minus pi over 2 to find that distance. Remember, that's just 1 pi over 2. That gives me 2 pi over 2, which is just pi. So now we know one period is just pi. And again, we do all of that to figure out the b value. So finding b, the formula period equals 2 pi over b. Once again, we now know that period is actually just pi. And then to solve, we'll put a 1 under that pi and cross multiply. Multiply left side, we have pi times b equals 1 times 2 pi. Well, that's still 2 pi. And visually speaking, I hope comparing the left and the right side, you can clearly see that b must be 2 for these to be equal. Or you can divide off pi on both sides. b equals 2. Questions on finding b or the period? Now that I've found the essential 3 variables, I can set up my equations and then I'll be able to finish them. Cosecant, we have y equals, we're going to determine if it's a positive or a negative a. Our a is 1. Cosecant, b is 2. X minus our phase shift will be determined shortly. Our vertical shift is negative 3. I'll repeat that for the secant equation below. Y equals, again, we'll determine if A is positive or negative. a, which is 1, secant b, which is 2, x minus phase shift, which I'll fill in a moment. I've already got that, minus 3. Again, cosecant pairs with sine and secant pairs with cosine. Now over here, I already wrote earlier what my phase shift is for the cosine slash secant curve, so I'll go ahead and fill that in. It's just pi over 2. And when I picked out that curve earlier, again, I was looking for one that started up at the max like it's supposed to, so there's no reflection. It is a positive 1. And I'm going to come up a little bit to write my new equation, or the improved equation. Y equals, drop the 1, secant 2x minus pi over 2 minus 3. And then I just need to find a starting point for sine slash cosecant, and I'll be done. We got to go back to the graph. Reminder, sine always starts on the midline. You have plenty of options. If you choose a point that goes up after, you're going to not have a reflection. If you choose a point that goes down after, you'll have a reflection. So choice is yours. Again, we actually don't know the numbers for those starting points. So again, it's easier if you start closer to 0. So I'm going to do that. So I'm going to start at this point here, this first midline point after 0. So this is going to be my phase shift, and once I figure out what that number is, I'll fill it in. And just for emphasis, I'll trace the curve. And remember, sine goes midline, max, min, back up to midline, and that's where it stops. Again, you can also have your starting point and go 4 points right. That's how you know you have your full curve. There's my sine curve, my cosecant curve. And let's figure out where we're at here. This is 0 on the left, and on the right, this is pi over 2. Again, that's also a half pi. Halfway between 0 and a half is a fourth. So this number right here is 1/4 pi. Meaning our phase shift is pi over 4. And that's for sine slash cosecant. So I can fill that stuff in. We have minus pi over 4 here. And again, I chose a curve that went up after the first point. So again, I intentionally chose one that didn't have a reflection. So 1 is positive. And lastly, I will write the improved version of that equation. Y equals cosecant 2x minus pi over 4 minus 3.